So titration is the lab that you did. What you need to know is that you have a burette and an Erlenmeyer flask. What's in the burette is a titrant, and that is going to usually be the base. In your lab it was NaOH, and it's of a known concentration. You need to know its molarity. Then you have your analyte, which is in our lab was hydrochloric acid, and then that is your unknown concentration. Now, we're going to use the fact that if you react sodium hydroxide and hydrochloric acid, that is a neutralization reaction, meaning that you are going to bring the pH to about 7. And when you have a pH at about 7, you can use stoichiometry to convert the concentration of sodium hydroxide to the concentration of hydrochloric acid. So, what we need in order to make sure that we've reached our neutralization, which is called our equivalence point, we need an endpoint. And that is the physical evidence that you have reached whatever equivalence point you want. We were using phenolphthalein, which is an acid-base indicator. It is colorless in acid and pink in base, meaning that if you had only acid down here, which you do at the beginning, it's going to be a colorless solution. If you added a lot of base and went past the pH of 7 to a higher pH, it'll turn bright pink. So what we want is in the middle. So the end point is a light pink because it is like about 7, more towards 8, but close enough. So that would be our equivalence point, our end point. And then you can do your stoichiometry to find your unknown concentration. So that is the point of titration, is to figure out what is the concentration of our unknown. So you guys have practiced that, so let's talk about how to do the math. So let's say you had an acid rain sample. You want to know, well, what is the concentration of the acid in that rain? That's actually important for environmental reasons. So what you do is you take a volume of your acid and you react it with a base of known concentration, and you figure out how much base you need in order to neutralize it, to get to that equivalence point, that end point. So what you do is you read your burette. Remember, you read the burette from the top to the bottom. If it has 0.3 initially, and then after the first trial, 11.1, the volume of NH that was used is 10.8 milliliters. Again, in the second trial, we started with 11.1, we ended with 21.7, so the amount of base used was 10.6 milliliters. So this is our volume of our NaOH, our base. That is where you're going to start your stoichiometry. What you need to know is the neutralization reaction. So you write your reaction. When you neutralize an acid with a base, you are always going to get water and a salt. In this case, the salt is Na2SO3. That is because SO3 has a charge of -2, and then you balance. What's important is the ratio of acid to base, because that is what we're converting between. Now the setup, the general setup is you start with your liters of base. You're going to multiply it by molarity of base, and that will give you moles. Well, after that, you need to change from one substance to another, the base to the acid, so that is your mole ratio. And then the very last step is if we have moles of acid, we want to know molarity. Well, molarity, don't forget, is moles over liters. So we divide by our liters of acid. So that is the steps every single time. So let's start with our first trial. 10.8 milliliters, remember we need to put it in liters of base, so I'm going to convert that to liters. Then my first step is to multiply by molarity. Remember, your molarity is going to be given to you because that needs to be known to figure out the molarity of the acid. 0.105 molar. Well, we're going to rewrite that as 0.105 moles of NaOH over 1 liter. So now we have moles of NaOH, we need to do our mole ratio. Well, we did our balanced equation to get that. For every 1 mole of sulfuric acid, you have 2 moles of NaOH. And the very last thing is we don't want moles of sulfuric acid, we want molarity. So we are going to divide by liters of acid, which you're going to know when you start. That's how much you put into your Erlenmeyer flask. Again, this is milliliters, so we changed our milliliters to liters. So when you plug in and do the dimensional analysis, you get that you have 0.0227 molar H2SO3. Now, in order to have a good idea, you need to do at least 2 trials, like in our lab. The more trials, the better, the more accurate and precise your data is. So in the second trial, it took 10.6 milliliters. So really, the whole conversion is exactly the same. What's different is your given. This time we started with this many liters of NaOH. So you're going to, again, multiply by the molarity of your known base. You're going to use your mole ratio to convert from base to acid. And then in order to get to molarity, you divide by your liters, which is the same for both trials. So plug that into your calculator. And you should get something very similar to the first trial, but a little bit different, 0.0226. All right, so that is our molarity for our second trial. And then we're going to take the average by adding the 2 molarities together and dividing by 2. So you just take the molarity from trial 1, add it to molarity of trial 2, divide by 2, and you'll get your average. I'm sure you can figure that out on your own. All right, that's how you titrate.